It's an experimental on partial replacement of coarse aggregate using e-waste in high-strength concrete. Abstract. Electronic waste is an emerging issue posing serious pollution problem to the human and environment. The disposal of the waste comprises as one of the major worldwide environmental problems as these waste render the environment unfriendly. Aim. The aim of the mix design is to achieve good quality concrete. Quality concrete means better strength and durability. Different design methods helps us to arrive at the trial mix that will give us required strength. Concrete is the basic engineering material used in most of the civil engineering structures. E-waste or electronic waste describes discarded electrical or electronic devices. Used electronic which are destined for reuse, resale and salvage, recycling or disposal are also considered as e-waste. Production of M60 grade concrete definitely requires materials of highest quality and their optimum proportions. These e-waste materials can be used as coarse aggregate and manufactured sand or artificial sand will be the suitable replacement for river sand. This will help us in protecting the environment from depletion of natural aggregates. Manufactured sand and has been used as fine aggregate. In this experimental study, e-waste to be used as partial replacement to the concrete ingredients, example that is coarse aggregate. The mechanical properties like compressive strength and tensile strength are to be measured for design concrete specimens. Materials were used in this are manufactured sand, ordinary Portland cement grade 53, coarse aggregate of size 16 mm, e-waste of size 16 mm, admixture magic fixing which is contrast. Methodology. Literature review, collection of materials, casting and curing for specimen, test on specimen and result and analysis are done. Collection of waste materials, e-waste were collected from the e-waste garden. Manufactured sand were obtained in the local shop and coarse aggregate according to the 16 mm size were received. Contrast WL were and Portland cement of 53 were used in that. Schedule of the project. The schedule of the project was designed and the starting process, then only the project has been done. Experimental plan. In this work, 0%, 5%, 10%, 15% and 20% of coarse aggregate is replaced by e-waste. Q specimen of size 150 mm into 150 into 150 are going to be casted for different proportions with e-waste. Compressive strength was performed on the concrete after 7 days, 14 days, 28 days respectively. Cylinder specimen of size 300 into 150 mm are going to be casted for different proportion with e-waste. Split tensile test was performed on the concrete after 7 days, 14 days, 28 days respectively. Test results. Sewer analysis results were given in this. Then specific gravity. The specific gravity of the bulk density, water absorption test, impact test, mix proportion. The mix proportion was according to IS 10262 2009 concrete mix proportioning guidelines. The calculated mix proportion ratio for M60 grade will be cement is to fine aggregate is to coarse aggregate is to water content to admixture 1 is to 1.919 is to 3.34 is to 0.35 is to 0.01. The slim cone test were given. The compressive strength of concrete cube at 7 days result was given. The graph of that for some 14 days the result and the graph of that 28 days and the result of that, the pick of it. Split tensile 7 days result, 14 days result and 28 days result was given. The next comparison of that were given. The comparison graph for compression test results which shows the 5% and 10% were implemented in split tensile test. And the conclusion, the experimental setting carried out during the present project work would lead to the following conclusion. Manufactured sand has similar properties of natural sand and it costs efficient than natural sand. From split tensile test, up to 15% of partial replaced concrete specimen has similar resistance to